Did you ever look up at the stars on a clear night sky in the countryside? If you did you try to count the bright stars? No matter how carefully you counted the stars, you couldn't figure out the actual number. You must have thought the number of stars is clearly endless. The infinity we just mentioned was a physical infinity, one of three major types. The other two are mathematical infinities and metaphysical infinities. What I'm going to talk about are mathematical infinities. You may want to ask, what are mathematical infinities? Mathematical infinities aren't only infinite quantities such as the ordinal numbers. They also include potential infinities, which are used more often. Potential infinities are procedures that get closer to infinite ends but never reach them. The concept of infinity wasn't fully formed all at once. Ancient cultures had various ideas about the nature of infinity. The ancient Indians and the Greeks did not define infinity as precisely as mathematicians nowadays, and instead saw infinity as a philosophical concept. Anaximander was attributed to the earliest use of the word apeiron. The ancient Greek term apeiron can be referred to as unlimited or indefinite. It might be able to be translated into infinite. Zeno of Elea was one of the first mathematicians to think about dividing things into smaller and smaller parts to show he doubted the existence of infinity units of time and space. Pythagoras thought the world was made of numbers and that all numbers were rational numbers. Zeno created four paradoxes. The two most well-known are Achilles and the tortoise and the arrow paradox. In this paradox, Achilles, a fast runner, is racing with a slow tortoise. When Achilles reaches the tortoise's starting point, the tortoise would have walked forward a bit and so on. Achilles would keep getting infinitely closer to the tortoise but never catch up. In Zeno of Elea's paradox, the paradox of the arrow, Zeno claims that if time and space are chopped into tiny pieces, then the flying arrow doesn't actually move. He said that each moment the arrow will be at a specific place. However, Zeno made a mistake when he thought movement was impossible in a world made of tiny blocks. Nowadays, we have cell phones and computers that chop up the moving images into discrete blocks. But the blocks are chopped so small, every bit of movement looks smooth. Later, Aristotle, another Greek philosopher, divided infinity into two types, actual infinity and potential infinity. Aristotle thought Zeno's paradoxes were based on actual infinity. Because of this, Aristotle believed that if you agree with the actuality of potential infinity and continuity, then you can understand Zeno's paradoxes. Aristotle's follower Euclid used the theory of potential infinities, but avoided infinitely small numbers. About 200 years after Zeno of Elea thought about space and time, Archimedes, thought of as one of the greatest mathematicians, used the concept of the infinitely small and his exhaustion method to prove many different geometrical theorems. Archimedes estimated the circumference of a circle by putting polygons close to circles and calculating their circumferences. Many funny stories show Archimedes as a person who was crazy about math. Some other stories portray him as a military scientist, a person making machines for a city to defend it against Romans. People aren't sure how Archimedes died. The most popular theory is that Archimedes was killed by an impatient Roman soldier who didn't want to wait for him to finish his math problem. Later, the Romans took over Greece. Greek math went to the backstage of history until the end of the Dark Ages. After thousands of years of being ignored, when math was recognized again, it was the Renaissance. During this period, many ancient texts and works of art were found. At this time, people were facing a new problem. They wanted to know how to calculate the parameter, area, and volume of shapes, the tangent of curves, the velocity and deceleration of objects, and the maxima and minima of functions. Now people needed a new field of math. The notion of infinity played an important role in solving the problems. In particular, scientists and mathematicians improved the method of exhaustion, or Eudoxus method. In this process, calculus was produced. By the way, the method of exhaustion was discovered independently in China by Liu Hui in the 3rd century AD and was used to find a circle's area. In the 5th century AD, Zhu Gengzhi established a way to find a sphere's volume, which would later be called Cavalieri's principle. Another person, René Descartes, can't be forgotten. He connected the previously separate fields of geometry and algebra into analytic geometry, which contributed to the creation of calculus. Wait, before I introduce calculus, there are some things I have to talk about. The infinity symbol, also called lemon skate or lazy 8, we use today, didn't always have a mathematical meaning. In ancient times, it was used as decoration. In 1655, English mathematician John Wallis introduced the infinity symbol as a mathematical symbol. In math, the infinity symbol is used more often to represent a potential infinity. Calculus, originally called infinitesimal calculus, is the mathematical study of continuous change. Calculus was independently developed by Isaac Newton and Gottfried Wilhelm Leibniz in the late 17th century. And as Richard Feynman said about calculus, it's the language God talks. Nowadays, infinity is used in many different fields. The lifelike characters you can see in animated movies like Frozen and Puss in Boots were made from many tiny triangles. Just like Archimedes made a parabolic segment from infinitely many triangles, animators created characters out of thousands of polygons. Also, before people had facial surgery, a model of the expected result would be made in the same method. Additionally, without the concept of infinity, we wouldn't have smartphones, GPS for lost travelers, or the capability to send astronauts to outer space. That's it. This is the end of the video, but my research about infinity has just started.